Hello everyone, I'm Kawai Wu. Today, I'm going to talk about one of the structural design patterns in software engineering, the facade pattern. Just like a building exterior only shows its outer look and hides all the inner workings, the facade design pattern works similarly. When people walk past a building, they only see its outer facade, not the internal wires, pipes, or structures. In the same way, the facade pattern hides the complexity of the system and provides an interface to the client from where the client can access the system. Imagine working with a broad set of objects belonging to a complex system. Typically, you will need to initialize this object, manage dependencies, and execute methods in the correct order. This complexity can make your business logic tightly coupled to the implementation details of third-party classes, leading to code that is hard to understand and maintain. The facade pattern is crucial for simplifying complex systems and providing a unified interface to a set of interfaces in a subsystem. It offers one main way to work with many parts inside the system. Think of it as having a straightforward remote for a complicated gadget. It helps us get a system that is simpler to use or fits our specific needs. The facade pattern typically involves three key players: facade, subsystem, and clients. As you can see from the diagram, there are 4 clients and 3 subsystems. Facade is the interface that clients interact with. It knows how to route client requests to the appropriate subsystem components. The facade's role is to simplify the usage of the subsystem. Subsystems are the individual components or modules that have specific functionalities. Instead of clients interacting with this subsystem directly, they go through the facade, which provides a simplified interface. Clients represent different users or components that want to utilize the functionalities of their subsystems. Instead of dealing with the complexities of each subsystem, they interact with the facade, which in turn communicates with the appropriate subsystems. Let's take a moment to pause and think. Can you think of a real-world scenario, perhaps in your daily life or in a different field, where a facade is used to simplify complex operations? How does the facade abstract the complexities and provide a simpler interface? Please pause the video and try to think of an example. I'll give you 10 seconds to do that. Now, I'll give you a real-world scenario example. Imagine planning a vacation. There are numerous tasks involved: booking flights, finding accommodation, arranging transportation, and planning sightseeing tours. Each of these tasks involves interacting with different systems and vendors, which can be complex and time-consuming. If you were to manage your vacation planning independently, you need to research and interact with airlines, hotels, car rental services, tour operators, and more. This process is akin to dealing with multiple subsystems in software, where each system has its own interface and requires separate handling. Now, consider using a travel agency. The travel agency acts as a facade, providing you with a single point of contact. You tell the agency where you want to go and what you want to do, and they handle all the detailed arrangements. The travel agency abstracts away the complexity of dealing with each travel service. This simplification is much like how a facade pattern in software engineering provides a simple interface to a complex set of subsystems, improving user experience and efficiency. Let's try a little exercise. Think about using a travel agency for vacation planning. How does this scenario resemble the facade pattern? Can you identify the facade, the subsystems, and the client in this analogy. I'll allow you 10 seconds to consider this. Feel free to pause the video if you require more time. In our analogy, the travel agency itself acts as the facade. It provides a simplified interface to the clients, hiding the complexities of vacation planning, which involves dealing with multiple different services like flights, hotels, and tours. The subsystems are the various services required for vacation planning, such as booking flights, hotels, and arranging tours. Each of these can be complex, having their own interfaces and processes. The client is the traveler or the person planning the vacation. By using the travel agency, the traveler doesn't need to directly interact with each of the individual services. Instead, the traveler deals with just one interface, the travel agency, which manages all the different services behind the scenes. This simplification and abstraction of complex processes are at the heart of the facade pattern. Now, let's see how this analogy translates into our Java code example. The travel agency facade class serves as a representation of a real-world travel agency, simplifying the vacation planning process. This example demonstrates how the facade pattern abstracts complex subsystems, providing a straightforward and unified interface for the client. Through this simulation, the agency manages tasks such as booking flights, reserving hotels, and crafting itineraries for sightseeing. Initially, the client may have to interact with multiple systems, a process that can be both complex and cumbersome. Now, consider the facade. We introduce the travel agency facades to encapsulate and simplify these operations. This facade offers a unified method to handle all aspects of vacation planning. Before the introduction of this facade pattern, the vacation planner has dealt with every facet of the vacation planning process directly, rendering the class complex and hard to maintain. However, with the integration of the travel agency facade, the tasks of vacation planner class are considerably simplified. Now, it merely needs to call one method on the facade to manage the entire vacation planning process. Internally, the facade handles all detail operations, leading to client code that's not only neater but also more understandable and easier to maintain. The facade pattern is not just a theoretical concept, it has practical applications in many software systems. For instance, libraries and frameworks often use facades to provide a simplified API to their complex internals. This makes the library easier to use and reduces the learning curve for developers. A real-world example can be seen in various web development frameworks. Frameworks like React or Angular offer a facade over the complex interactions of the document object model, events handling, and state management. Developers interact with a simplified interface provided by the framework, which internally manages the complexity of browser compatibility, document object model updates, and user interactions. While the facade patterns offer significant benefits, such as simplifying the interface of complex systems and reducing dependencies, it's not without drawbacks. One potential downside is that it can become a single point of failure. If the facade is poorly designed, it can lead to system failures or performance bottlenecks. Moreover, while a facade can streamline the use of a complex subsystem, it might also limit functionality. Since a facade generally provides a reduced set of functionalities compared to the subsystem it abstracts, There may be instances when clients need to bypass the facade to access more intricate functionalities directly. Therefore, striking a balance between the simplicity provided by the facade and the needs of the client is essential. The facade should be designed to offer the most commonly required functionalities, facilitating common tasks while still permitting access to the more complex capabilities of the subsystem when necessary. In conclusion, the facade pattern is a powerful tool for software engineers. It helps in managing complexity by providing a simplified interface to complex subsystems. Like any design patterns, its application should be determined by the uniqueness and content of your project. So that's for this video. I hope it was helpful. Thanks for watching.